Hi, ladies and gentlemen. This is something I've never done before, and I'm going to hopefully see if this will work out for your benefit. Today, we're going to begin with lesson 7.5. This lesson is titled Exponential Functions. We're going to start out with the vocabulary today. First of all, exponential function. You can stop this video at any time you need to and write things down. I'm going to be going pretty fast, so you probably will need to do that. If you're doing this on the notes, most of it's written out for you. If you are copying this down on your own piece of paper, you will probably need to stop this video often to copy down what I have here. We're going to be using the whiteboards today. So first of all, exponential function. A function that can be described by an equation of the form y equals a to the x, where a has to be greater than 0, and it also cannot be a 1. Next, we have exponential growth. When an initial amount increases, when you think of something growing, you think of it as increasing. So when an initial amount increases by the same percent over a given period of time. Well, if we think of exponential growth as increasing, then exponential decay would be decreasing. When you think of something decaying, then it gets smaller. So the definition for that is when an initial amount decreases by the same percent over a given period of time. Next, we're going to move on to some examples of exponential functions. You can see exponential functions where you have a product raised to a power, like here, 2 times 3 raised to the x power. X could be any number. You could also have a single number raised to a power, like we have here. Y equals 1/2 to the x power. So all exponential functions will have a power. Okay, let's look at example 1. It wants us to graph y equals 4 to the x power. Find the y-intercept and then state the domain and the range. If you think back to some previous lessons, domain is x values and range will be our y values. It gives us this table in our notes and tells us that when x is -1, y is 1/4. So if you were actually to substitute -1 in for 4, you would get 1/4. And in our table, 0 is 1, and the x value for 1 is 4, and the x value for 2 is 16. So you simply plot these on your graph. So go to -1 on your x-axis and up just a little ways to 1/4. 0, you will go up to 1 on your y-axis. When you're at 1 on your x-axis, you will graph at a 4 on your y. And when you're at 2 on your x-axis, you will graph all the way up to 16. Go ahead and connect your points. And what do you notice about exponential growth? Starts out small, and since it's increasing by a certain percent, it gets large very quickly. Okay, now let's look at where our line crosses the y-axis. Well, it tells us in our table that we had when we're at 0 for x, it crosses the y-axis at 1, and you can also see that on your graph. So your y-intercept is 1. Then it asks us to talk about all of the domain. So if we're looking at the domain, which is our x-axis, keeps going on the left, so it gets smaller and smaller and closer to the x-axis. And if you look at the end of our graph on the right, it continues to go up. So we could say that our domain is all real numbers because they will be negative and they will be positive. Now let's look at our range. Our range is everything on our y-axis. Do you notice that our line never goes below the x-axis? It always stays above. So will any of our values ever be negative for this graph? No, they will not. So we're not going to say it's all real numbers because it's actually just above the origin, and it will be all positive numbers. All positive numbers. Okay, let's move on to example 2. On example 2, we have y equals 4 to the x power, and this was our graph off of example 1. We need to determine the approximate value of 4 when x is 1.5. So when you go over here to your x-axis and you look at 1.5 and you go up, looks like it touches at about 8. So when x is 1.5, y would be 8. You can check this by putting it into your calculator for your caret sign and 1.5, and you will get 8. All right, now let's go on to example 3. On example 3, it wants us to graph 5 to the x power. First thing you're going to do is make a table. And we've talked about when you make a table to graph, you want to focus on what's in the middle of your graph. And a good way to do that is to choose x values such as -2, -1, 0, 1, and 2, and then see what you get for the y values, and then graph your points. So let's go ahead and do that. Make your graph or your table for 5 to the x power. Now, if we put in 5 to the -2 power, you're going to get 1/25. So fill that into your table. If you graph 5 to the -1 power, you're going to get 1/5. Anything to the 0 power is 1. 5 to the first power is 5. And 5 to the second power is 25. Write all of this out so you know what goes into your table. When we have -1 for x, we have 1/5. 0 for x becomes 1. 1 for x, y would be 5. And 2 for x, excuse me, y would be 25. So we're going to use this information to graph. We talked about -2 being graphed at 1 to the 25th. And you might be thinking, Mrs. Edquist, I have no idea where that's at. Just know that it's between 0 and 1 on your y-axis. The further you go along your y-axis to the left, the closer it's going to be getting to the y-axis, but it's not going to cross. And then when we had -1 for x, y is 1/5. When 0 was x, y was 1. When 1 was x, y was 5. And when 2 was x, y was 25. So you can see the exponential growth here as we go from left to right on our x-axis. Let's go ahead and look at example 4. On example 4, it has us graphing y equals 1/4 to the x power. So go ahead and make your table like we talked about. And in your x values, you'll put in a -2, a -1, a 0, 1, and 2. Now let's work through these. When we start out with 1/4 to the -2 power, I hope that you remember when we have negative exponents, that means to flip your fraction, and then it becomes 4 squared, which is 16. Then we have 1/4 to the -1 power, again flip, and you have 4 to the first power, which is 4. Anything to the 0 power is 1. And if you look at the next one, 1/4 to the first power is 1/4, and 1/4 to the second power is 1/16. So go ahead and fill in your chart. For -2, you had 16. For -1, you had 4. For 0, you had 1. For 1 was 1/4. And for 2 was 1/16. So let's go ahead and plot those. -2 is at 16. -1 is graphed at 4. 0 is graphed at 1. 1 is graphed at 1/4. 2 is even closer to our x-axis. Connect your points. And here we have an example of exponential decay. So what is the y-intercept? You can look at your table and you can look at your graph and decide, well, I think that it tells us it's at 1. Domain. What does it look like is happening along our x-axis? We have negative values, we have positive values. So once again, our domain is all real numbers. Then you look at your range. Well, it appears that our graph is only in the positive numbers section and does not fall below the x-axis, so there are no negatives here. So our range, once again, would be all positive numbers. Okay, let's go on to example 4b. We have to use our graph to approximate what is 1/4 to the -1.5 power. So let's look. -1/4 to the -1.5 5 power. Well, negative 1.5 is about right here on our x-axis. So I believe, according to my graph, it crosses at about 9. Remember, these are estimations. Now, if you put it into your calculator, 1/4 to the negative 1.5 power, by typing in 1/4 raised, put in parentheses, negative 1.5, you don't get 9 this time, but you get 8. Remember, graphs are approximates. They're estimations of what we plot, and putting it into a calculator will give us an exact answer. So I would say we were pretty close on this. That is all I have today for lesson 7.5. If you have any questions, you can email me at cedquist@mg.k12.mo.us. Thank you.